Today we're going to move from ratio tables to equations using the value of a ratio. George wants to make a custom color orange paint, so he's going to mix 3 gallons of yellow with 1 gallon of red paint. So here's George's 3 gallons of yellow and 1 gallon of red paint to make his custom color of orange. Now we could look at this and we could say that the ratio is 1 gallon of red for every 3 yellow, or we could flip it and say that for every 3 yellow gallons there's 1 red. Doesn't matter either way. Based on all this information though, let's fill out this table. Alright, for every 3 things of yellow paint, there would have to be 1 thing of red paint. If I wanted to know how many things of yellow paint I would need if I had 2 red, well, 2 red is double the 1 gallon of red that I had before, so I would just double my yellow paint to get 6 gallons of yellow paint. To find out how much red paint I would need after 9 gallons of yellow, well, 9 is 3 times as many as the original 3 gallons, so I'd need 3 times as many of the original red gallons, which would give me 3. And of course we're going to do the same for the 12 gallons of yellow paint. 12 gallons is 4 times as much as the original 3, so the red would have to be 4 times as much as 1 would be 4. 4 gallons of red paint. And lastly, 5 gallons of red paint is 5 times as much as the original, so 5 times as much as the original yellow would be 15. Now we're going to describe each relationship between all of these values. For instance, the relationship between 1 gallon of red paint and 3 gallons of yellow paint is 1 times 3 gives us 3. The relationship between 3 gallons of red and 9 yellow is 3 times 3 gives us the 9 yellow. So the relationship between 2 gallons of red and 6 yellow is that it's 2 gallons times 3 that gives us 6. And the relationship between 4 and 12 is 4 times 3 gives us the 12 yellow. And lastly, 5 gallons of red paint times 3 gives us 15 yellow gallons. Now take a minute and in your own words, without worrying about numbers and values, tell me, what kinds of information is this table telling us? Simply put, this table is telling us the number of gallons of red paint and the numbers of gallons of yellow paint that would be needed to make this exact orange shade of paint. Why in the world would somebody need this table? One possibility is for painters who need to use a lot of paint to maybe cover a building. Instead of just using 3 gallons of yellow and 1 gallon of red, they would need to figure out how many times that ratio they would need in order to cover the whole building. So using this table, answer the question, if we used 5 gallons of red paint, how many gallons of yellow would we need? We would need 15 gallons of yellow paint. And we know this because we can look at the bottom of the table where it says 5 gallons of red would need 15 gallons of yellow. What's the general relationship between yellow paint and red paint here? Well, if we look at all of the relationships, we know that each time we have red, we multiply it by 3 to get yellow. So the relationship is that yellow is 3 times as much as red. Now, what if we had to cover an entire part of a building and it needed 100 gallons of red paint? How many gallons of yellow would we need to mix with that red in order to cover that building? Well, because we now know that the relationship between red and yellow is that red multiplied by 3 gives us yellow, we would simply multiply 100 by 3. Okay, let's take all of this talk about the relationship between these two and turn it into an equation. We know that we need to multiply red, which we can call R, by 3 to get yellow, which we'll call Y. So what if someone gave us Z gallons of red, like any number in the world gallons of red? How many gallons of yellow would we need? We would need 3 times as much red. So however much red we have, we would have to multiply it by 3. And so how would we write this in equation form? Y, yellow paint, is equivalent to 3 times as much as whatever red there is. And what if the opposite was true though? What if we weren't told how much red paint we needed, but instead were told how much yellow paint we had to use? How would we figure out how much red if we were told how much yellow we have? Because yellow is equivalent to 3 times as much red, and if we are told how much yellow to use, to find out the amount of red, we would simply do the opposite. We'd take that yellow and we would put it into 3 groups. We'd divide it by 3, and that would tell us how much red we would need. So what would the equation be if we wanted to know how much red and we were given yellow? Well, we would take the yellow value and we would divide it by 3 like we said. So in other words, dividing by 3 is the same as multiplying by 1/3. So the equation would have to be R, red in this case, is equivalent to yellow being divided by 3, or 1/3 of Y. Okay, George has a whole nother plan. He wants to mix red paint and blue paint now to make purple. For George's custom purple color, he decides the best mixture or best ratio is 4 gallons of red paint to every 1 gallon of blue paint. Okay, George can only buy paint in 1-gallon containers. So we're going to make a table now that shows us all the possible combinations for red and blue paint that will give George no more than 25 gallons of purple paint. And so here's our table. We have our blue paint and our red paint and the total amount of paint, because remember, we didn't want to go over a total amount of 25 gallons. So for every 1 gallon of blue paint, we need 4 gallons of red paint. That was what we were told. So for 2 gallons of blue paint, we would need then double the amount of red paint, which would be 8, and so on and so forth. And if I wanted to know how much gallons of purple paint each set of values is, I simply add them together. That tells me how many gallons of purple paint I'll end up with. So your table should have looked like this. Now let's write an equation that will let George calculate the amount of red paint that he'll need for any amount of blue paint. Okay, any amount of blue paint. We'll call it B, and we just saw that 4 times B, 4 times the amount of whatever blue is, will always give us red, or R. What about if we wanted to write an equation to calculate the amount of blue paint that you'd need for any amount of red? It would be the red paint divided by 4, and that will always give us the amount of blue paint. Now if George has 24 gallons of red paint, how much blue paint will he have to use to create the color purple he wants? Red divided by 4 equals B. Let's use this information. We know that in this case the red is 24 gallons. And so 24 gallons of red paint divided by 4 will be 6 gallons of blue. That's how much he will need to make this purple color. What about if George has 24 gallons of blue paint? How much red paint would he need to make his purple color? Well, if 4 times the amount of blue always gives us red, then 4 times, in this case, 24 gallons of blue paint will give us 96 gallons of red paint. What if we wanted to write an equation that shows the relationship between blue paint and the total amount of paint? Okay, check this out. If the total is always the amount of blue plus the amount of red, and that gives us the total amount of blue and red, then all we need to do is take our blue gallons, so B, and add it to our red gallons, which we know is B times 4. Red gallons are always 4 times as much as blue gallons. So the total will be blue gallons plus the 4 times blue. That is equivalent to red. Alright, new exercise. During a particular U.S. Air Force training exercise, the ratio of the number of men to the number of women was 6 men to every 1 woman. If we have a table, we fill it out like this. 1 woman to every 6 men, 6 men to every 1 woman. I want you to use all of this information now on your own to create 2 different equations that would show the relationship between men and women. One possible equation is that the amount of men will be equal to the amount of women times 6, because we were told that 6 times the amount of women is equal to men. Another equation we'd come up with is just the opposite. The number of women is going to be equal to the number of men divided by 6. So if 200 women participated in this training exercise, then which of these equations would we use to solve the question of how many men are there? Well, if we want to know the number of men, then let's leave that variable on its own. So let's choose the equation that has men by itself. Okay, so the equation of the amount of men is equal to the amount of women times 6 is going to be the one we'll use because we know the amount of women is 200. We can plug that in for W. And so the amount of men is simply 200 times 6. And 200 times 6 is 1200, so the amount of men, if there are 200 women, is 1200. So, summing up everything we've worked on today, going from ratio tables to equations, we've been reminded that the value of a ratio can be determined using ratio tables, and that from there, we can use that found value to make an equation that also represents the ratio. So we've used ratio tables, we've found their relationships, we've looked at the value of the ratio from the ratio table, and then we've taken that and turned it into an equation which can further help us in determining information.